Hey, welcome back to Fat Mama Physics. In this video, this is part 3 of section 3.1, modeling and polynomials and looking at like terms. So what we did is we looked at examples of like and unlike terms. We looked at example where we simplified a polynomial by combining the like terms. And in this video, we're going to look at a harder example with combining like terms and maybe a word problem as well. So let's get started. Simplifying a polynomial in two variables. Here we go. Let's see. These are actually the same question here. So we just have to simplify one of them. And the only thing about this one is that it has more, it has two variables, x and y, as opposed to just the x, which shouldn't bother us at all. Remember, we are still able to determine which ones are like or unlike terms. So let's begin. Let's take a look at the first term here, which is x and y. So I'm going to box that and find another term that looks the same. I have xy here, 2xy. Okay. The next one I have y squared. Now, when I include this term, I have to include the negative sign as well. So I have negative y squared here, and going along the sentence, I have another y squared, but this is negative 3y squared. So also circling that negative to be part of that as well. Last but not least, I have x squared. That's my third different type of term. And let's use a triangle for this case. Oh, that's ugly. And so I have negative 3x squared, and then there's another, ooh, that also almost got me. But notice that x, that's the only x squared, and negative x is, it's by itself. So let's just underline this guy, okay? Next up, we are going to match up the terms together and rewrite that as a separate sentence. And what is preferred actually is when we rewrite the sentence, anytime when you're rewriting a polynomial, you always want to go from a higher degree to a lower degree. Now, when the degrees are the same, we want to classify them in alphabetical order. So we know that x comes before y. And this, so here we have x squared. This is a degree of 2. This also has a degree of 2 because it's 1 and 1. So 1 plus 1 is 2. This has a degree of 1. This has a degree of 2. This y2 has a degree of 2. This xy also has a degree of 2. Okay, so what actually has to go first is the pure x squared. That has to go first. So I'm going to, when I rewrite this, I'm going to write negative 3x squared first. Looking at all of the different terms that have a degree of 2, I pick one that is next up. Cannot be y squared because y is later in the alphabetical order. I need to pick xy. So that's kind of in between the x and the y there. So I'm going to rewrite here this. Anytime I have a number that starts off my sentence but has no plus or minus in front, it always has an imaginary plus sign. So here I'm going to add 4xy. This is, the green one here is plus 2xy. Then I can put in my y squares because that's after in the alphabetical order. And of course, I have to do that before I do the x to the power of 1, since x to the power of 1 has a smaller degree, has a smaller exponent than all of my other terms. So here I have minus y squared, then minus 3y squared. Okay, so those are done. And last but not least, I have the singleton minus x to the power of 1, which is why it is last. So double check, we have all of these terms. We've included all of them in our sentence. And now we can go ahead and simplify. We have negative 3x squared is by itself, cannot be simplified even more. 4 plus 2 is 6. So plus 6xy. Next up, we have the blues. -1. So remember, if it's just a minus in front, this is an imaginary -1 in front of y squared. Okay, so I have -1 minus 3 gives us -4 in total. Okay, and last but not least, I have a singleton minus x. And there we go. If I want to rewrite it, it's going to look like this. And here we go. This is the solution to this one. Okay, last example where we're going to have to do some word problems. So here we go. We have investigating situations where we represent polynomials. So in this case, we are going to write an equation for the perimeter. And I did say I hate the way how this is represented, but we just have to go with what this is trying to show us, unfortunately. So the reason why I want to do these problems is just to remind us what polynomials are. Sorry, not that's a dumb expression. What perimeter is. Okay, so perimeter is the total length of an outside of a shape. So for this shape here, it would be the length of all of the sides combined. So what that looks like is, if we want to write a polynomial to represent the perimeter of each rectangle, then let's take a look. We know that one side here is x. This is another x, that's another x, and that's another x. So it seems like the length is just 3x, and then the width is just 1x. So if we want to, we could say that since perimeter is 2 times the length, or basically counting up all the sides, then that is just, I have 3x up here, I have 1 over here. I could just count up the number of x's going around the circle. That's 1, 2, 3, 4, 5, 6, 7, 8. So I could just write 8x just to make things simple. Okay, there, that's A, done. Woohoo! Next, A2. In this case, our perimeter, the top is 3x. I'm also going to have 3x here on the bottom. So that's going to be a total of 1, 2, 3, 4, 5, 6 x's. Okay. And then I'm going to have a singleton of 1 unit here, 2 units here, 3, 4 units. Therefore, I have 4 separate units here. So 6x plus 4. So that was easy. I just counted up all the sides and did that. But remember, perimeter is essentially if you add up the side lengths of every side. And if it's a rectangle, you have 2 lengths and then you have 2 widths. But of course, I'm not going to write that down because it's going to, it really depends on the situation. And I don't want you getting locked in any scenario. But I can write the definition of perimeter down for you. So here we go. The perimeter is the sum of all the side lengths of a shape. So you have to add them all up. All right, so let's take a look at B. Each polynomial represents the perimeter of a rectangle. Find the dimensions of the rectangle. Ooh. Yes, B is a bit tricky, which is great. Love it. Okay, so here we go. We have 4a plus 2. And the easiest way to kind of work that out is to first of all draw a rectangle, just to help you visualize what it looks like. So let's say I have a rectangle here. Okay, I know that the perimeter, let's say I have a side length L, and I have a width here, and I have a width here. So I know that my perimeter for my rectangle is going to be, and P is going to be perimeter here. This is going to be 2L plus 2W. Okay, since I have 2 L's in my rectangle and 2 W's in my rectangle. So if we take a look at this set, it almost seems very straightforward just to say that the 2, it represents the side with the width, and then the 4a represents the side with the length. So that 4a is equivalent to 2 side lengths, meaning that all we have to do is divide 4a in half. So that dividing 4a in half is going to give us 2a because that's 2 side lengths. As for the width, we can say that the width is just equal to 1. So on this diagram, what that would look like is I would have width is equal to 1, and then the length is equal to 2a, meaning that if I split this, it will just look like this according to the top diagram, which I really hate, but I'll just have to show it for the purpose of this question. So it will look like this. Here, I'll erase that just for clarity. So essentially what we have now is we have a, and a 1. So I have 1, 2, 3, 4 A's, and then 2, 1, 2 for the width. So this is a legit model. I actually think there are other possibilities, but I'm going to leave that as this. Maybe I'll leave it as a challenge to figure it out, maybe. Okay, so there you go. We have to write this as a sum of equal pairs of terms. Well, guess what? Maybe we can say this is just 2 times 2a plus 1, which is the sum of 1 length and 1 width. Okay, so we can do that. And in an actual question, a proper question will actually give you some hint as to what the area is, so that you're not given so many different possibilities of what the answer could be. Because I could very well divide this box a different way according to 4a plus 2. Okay, but here this is one of the solutions. I'll put it that way. This question is not important enough for me to actually elaborate more on, so I'm just going to move on. Okay, 10b. Let's, again, always good to draw a picture, okay? And we want 10b as, well, we essentially want, we want, again, the perimeter of a rectangle is 2 times length plus 2 times the width. Now, in this particular case, it's a little bit trickier, I guess, with only the one term, to be able to split that up, but we know we can split 10 in half. So why won't we do that? Why won't we split 10b into 5b plus 5b? Okay, hopefully this way we can do something about that. And I think it's actually better if I write it this way to help give us a little bit a better idea. So instead of writing like that, maybe what I'll do is, this is essentially 2 times 5b, okay? And when we deal with the perimeter, this is essentially 2 times the width plus the length, or vice versa. So based off of rearranging the actual perimeter and the equation of the perimeter for a rectangle, then we can match these two things up. Here the 2's match up. Here the 5b is going to match with the length plus the width. So essentially what I have is I have 5b is equal to the length plus the width. Okay, so one possible solution is if my length was equal to, well, actually it should be longer, so 3b plus 2b being the width. So if we did that, then it's going to look like this. So if I separate this out into 3 sections, this is a B, this is a B, and this is a B, and I separate like this is going to be, and this is going to be a B as well. So my length is 3B, and my width is 2B. If I count the total B's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 B's total, this is legit. Okay, so that, oopsies, this should be length plus width. Okay, so there you go. If I have to write this properly, then I would say that the perimeter is equal to 2 times, let's make that smaller, 2b plus 3b. Okay, there you go. All right. All of these silly questions are done. So I will call that the end of 3.1. So I thank you for watching. Stay tuned for 3.2 and 3.3, which we get to talk about more meatier stuff. So wish you the best of luck with your practices. Thank you for watching. Fan Mama Physics signing out.